Today I'm talking to my guests, Jordi Cruz, he is CEO of Zentinel, and Björn Engelbert, he is business developer at Perinet. We're talking about technology-related use cases at source level, so it's all about data acquisition, data standardization, and also at integration level with use cases around data transmission. And this episode is great for all users who want to implement use cases at shop floor level or in the building segment. It makes no difference in which functional area you are in. And we're clarifying questions like what you should pay attention to if you want to implement standardized data collection, how can different machines or asset types on existing shop floor can be integrated, and which components are used here to save money. You will get these answers now, and as always, you will find all the information at iotusecase.com. Let's go. Hi, Björn, and hi, Jordi. It's very nice to have you. Yeah, Björn, how are you feeling today?
Yeah, hi. Thanks for having us, Madeleine. All well. Looking forward to the podcast, actually.
Perfect. Yes, and how are you, Jordi? How's your day going?
Very well, thank you, Madeleine. We are very pleased to be together in this podcast. So looking forward to the conversation.
Perfect. So maybe we could start with a very short introduction of you, because I know we had our discussion before, but it's really interesting to learn more about you as a person. So maybe, Jordi, we could start with you, because you have your background a bit at Harting, right?
Yeah. Many years ago, I spent a lot of years working for Rockwell Automation and for Honeywell. So we've got a lot of insights into the automation, control and information. And then I spent 10 years at the Harting Technology Group. I was the managing director of Harting Iberia. And during that time, Harting introduced a revolutionary industrial edge computer that ended up as a spin-off of the Harting Technology Group in the company called Perinet. So This is how we knew each other. When we decided to create our own company in Spain, Perinet was the obvious option for the technology that we were going to use for our company.
Nice. So greetings to the Harting teams, if somebody's listening right now. And Björn, when did you first met Jordi then? So was it years ago or was it recently?
Yeah, actually it was years ago. I already know Jordi from his time back at Harting Iberia. We were in good contact because already back in the days when Jordi was still at Harting Iberia, we were together looking at use cases for the edge computer that Jordi just mentioned. And when we then finally took over the IP for this edge computer from the Harting Technology Group, as Jordi mentioned, I mean, basically we continued to work together on use cases that would be based on that technology. And Jordi and his colleagues have actually taken the base products that we provide and developed them further to actually give a value-added approach to the market.
Yeah, I think we will have a deep dive anyway in how your technology works, but maybe we could start a bit about like what kind of use cases are covered in the different projects. And then I guess we are paying attention to, what I have to pay attention to if I want to implement projects like this. But maybe Björn, to have a very short introduction. So Perinet is providing these IoT components and the technology. Can you explain a bit what your customers are and what kind of use cases you're covering in your projects?
Yeah, absolutely. So we are a spin-off of the Harting Technology Group, but we are relatively small. I mean, we are around about 20 people. Our focus is on the development and marketing of the base components, as you just said. So it is basically a range of components that enable customers to directly get information from the field level. We are using technology called single pay Ethernet as a conduit for that to make field level components. And with that, I mean mostly sensors and actuators, make them networkable and give them all the benefits that come with networkability. So a very flexible approach to topologies that can be rolled out in the field, security, browser-based configuration, browser-based dashboards. You make your sensor or actuator on the field level. Basically, you turn it into a network computer with our components.
Nice. And how that works, we will also get an insights about that later. And if you're now wondering what is SPE, so if you hear that, we will explain it in a second. So sorry, Björn, for interrupting.
Yeah, no problem. Actually, so we are a pure base component provider. And our clients are first and foremost sensor and actuator OEMs, so original equipment manufacturers that use our Pericore communication module to give their product range these features of networkability, security, and so on. And we are active in different markets. So Basically, we have identified first and foremost, obviously, industry, but as well building automation as our target markets. But then the probably most important customer segment that we have is actually value-added resellers such as Zentinel, because we are focusing entirely on the base product. But what we are not able to do is that we adapt our products to the concrete market needs. And for that, we need value-added resellers, system integrators such as Zentinel to basically then adapt the product to what the clients actually want to do with it.
I see. So you're partnering to create kind of a whole solution for your customers, but then you're partnering with Zentinel in this area.
Correct.
Yeah. And so, Jordi, can you explain a bit about the partnership of Zentinel and what kind of use cases you're covering? So you're more on the technical use case level. So you're on the field and source level. So it's all about data acquisition use cases and maybe data standardization. And Jordi, where are you coming in this area then?
Yeah, Perinet started with an edge computer, an industrial edge computer, which nowadays is a pretty popular term, but back in 2015, it was pretty revolutionary. But they have expanded this concept to have these intelligent adapters that can read the signals of machines or sensors and put that information on single pair Ethernet. What we have done at Sentinel NDS is take advantage of the additional computing power that is available in these low-level adapters, and we have added information processing capabilities at the signal level in these adapters so that the user, in some cases, does not even need to use an edge computer, and for sure does not need to go to the cloud to do the data processing. So, for example, a typical parameter that manufacturers use is the OEE, the overall equipment efficiency. The traditional way of calculating the OEE is to read the signals with some form of low-level computer and then upload those signals to a higher-level computer that will do the calculation and then measure the uptime, downtime, quality index, productivity, etc. We can do all that in a simple Perinet Perinode, and it's calculated in real time locally. So this can be sent directly to a database somewhere in their system.
A lot of listeners right now are setting up typical use cases around OEE and the calculation of that. So that's a very great example to understand how your technologies are working. Can we dive a bit more into the challenge or the pains behind that? Because when we're talking about this typical use case, there are different also technology-wise challenges and pains people are addressing today. So can we talk about the technology challenges behind that? So Jordi, you're mentioning OEE. So what's the technology or the technical challenge behind that to solve this use case?
Yeah, the typical situation in the manufacturing industry is that these companies have done big investments in information systems and they have done big investments in automation. But automation does not necessarily mean digitalization. And in many cases, to get the data from the automation controllers, the PLCs, and to pass the data to the information systems is very complicated and very expensive. Unless you have done a very careful planning of making sure that every machine has the same type of controller with the same data structure in the memory of the controller, extracting the data from the machines can be very expensive and very difficult. So what we are addressing is the fact that getting data from the controller is difficult and expensive. So therefore, we're not going to go to the controller. We're going to read the signals directly from the machine. And this is what the Perinet technology allows us to do, because they have low-level devices with significant computing power so that we can read the status of a discrete output on a PLC, and out of that single signal, which could be the end of cycle of the machine, with that single signal, we could be inferring locally what is the average cycle time, what is the number of pieces produced, what is the downtime of the machine. And this is, I think, pretty revolutionary.
Yeah, maybe to add to that, I mean, what Jordi just summarized basically is the mission of Perinet. I mean, we have, before the company was founded, we have experienced basically from a lot of participants in the industry that they wanted to work with the data, they wanted to digitalize, but they found that it is very, very cumbersome and it's a large effort basically to get to that information It is usually, or it was usually, associated with a large amount of time, a large amount of manpower, and also a large amount of cost, as Jordi just mentioned. And basically from those pains that we've seen in the industry, we have derived our mission, which is to basically provide those components that make data acquisition on the field level very, very easy and very efficient, and also very economical. And on that basis, companies such as Zentinel, for example, can then really create the use cases that give the participants in the industry very, very fast and easy results to what they actually want to achieve.
So, Jordi, when you talk about the different data acquisition cycles, so you talked about different signals you need from the PLC level. Could you just explain what kind of data types we are talking about? Because in some podcast episodes, we're talking about like massive data, real time. Like, what kind of data types are we talking here about?
Yeah, because the Perinet adapters allow us to read the signals directly from the machine. It can be PLC outputs, it can be a photoelectric sensor measuring parts that are passing by. We are dealing typically with simple on-off signals to detect cycle times or production pulses from utility meters, analog values like pressures, temperatures, levels, etc. So we are working at a very, very low level, which has the benefit of reducing the amount of data that has to be transmitted across the network.
Mm-hmm. And when we talk about amount of data, like, is it these typical data, are these sent per minutes, per second, per hour? Like, how often are these data types sent?
With single-pair Ethernet and the Perinet components, we can go as fast as 10 times per second. So every 100 milliseconds, we can upload a package of data, of processed data. So technically, we could be updating, for instance, the OEE of a machine or the evolution of an analog signal every 100 milliseconds. So there's really not a need to do it that fast. But it's user configurable. So the user can decide I need it every minute, every 10 seconds, or every 100 milliseconds.
I see. You talked about data types more from like the real-time data of the different assets and PLCs, for example. What about IT system data? Are you also integrating typically in those kind of use cases IT systems, or is it just like real-time data from different asset types?
Well, we believe we provide already information so that the user use that information directly. Basically, we are all standards-based, so we have two main mechanisms for sharing the data. We use MQTT as the real-time protocol, so everything that the sendouts are producing is published to an MQTT broker, and then the user can access the data in real time through that MQTT broker. But we also have running in the Perinet edge computer, we have a SQL database. So it's an industry standard structured query language database. And any product that can read data from a SQL database, Excel, Power BI, any other database can have access to the information.
I see. Okay. So to solve this use case, it's not just real-time data from different PLC, but also IT system, which are used and information of different systems on the IT level. Okay. There are different requirements customers have, I guess. So do you have any insights about the technology requirements people were asking for your solution? So what's important for your customers' requirement technically?
Well, basically, what they want is the information. We are finding customers across all the rainbow, from companies that are quite advanced in their digitalization strategy, from companies that are just starting. But at the end, what they want is the data. So that is what we're getting is that, well, we could be talking hours about how cool our solution is and the MQTT protocol. But at the end, customers, they don't really care as long as what they have is available in an open format so they can connect their IT systems. So that's basically what we're getting is they want something that is open, that is simple to implement, that doesn't require re-engineering the machine, and that they can plug their information systems and read information.
All right. So maybe let's start in the next chapter to have an understanding how your solution is actually working together. Because as I understood that right, you have an integrated solution. So the one part is coming from Perinet, more the hardware related and data acquisition part. And then from Zentinel, there is an integrated solution for different types of customers. So could you explain what the solution is exactly, like in a few sentences. And then I would ask a bit more how the data collection is working, the data transmission, so that we could jump into some details here. But what can exactly the solution do for customers here?
Traditional, let's say, Industry 4.0 system made of PLCs scale as an information system. The PLC is responsible for reading the signals from the machine and then converting those signals into data, temperature, counts, etc. Then that information is passed typically to some form of a SCADA system that converts that information into, let's say, IT-ready information to simplify the subject. We are doing this by moving everything one step down. So converting the signal into data is done with the Perinet devices. So we read the signal, and here we calculate directly cycle times, temperature, alarms, etc. is done locally. So from an IoT perspective, the Perinets are doing what the PLC would be doing. And then instead of using a high-end PC-based server or multiple servers with a SCADA system, a historian, etc., we are having all that in the edge computer from Perinet. So in the edge computer, we have an MQTT broker that receives the information that is published by the local devices. And in the edge computer, we have a SQL database that is logging every single package of information that is arriving to the system. It's as simple as that.
I see. Okay. So the first step then is the data collection, which takes place, Björn, with your components from Perinet. So what kind of product is that here? What should I pay attention to if I want to implement a standardized data collection here? So what's important from hardware side?
Just to add on to what Jordi just said, I mean, our focus is really what is generally known as IT-OT convergence. So basically bringing our information from the field level up into IT systems to be, analyzed and for people to get a better idea of how their production is working. And then, as a follow-up, then being able to make those adjustments or to optimize. So we are no means competing with automation systems, but we are entirely focusing on data acquisition. And then what the client does with that information that comes from our devices is up to them. Or rather, companies such as Zentinel then build the use cases that make direct sense to them, to the clients on the basis of our product. So the Perinodes that Jordi mentioned are smart adapters that can be directly attached to any kind of sensor or actuator in the field. Hereby, the most important thing is that we have a variety of different interfaces depending on what kind of sensor or actuator you have. I mean, we have, for example, a 0 to 10 volt interface. We have a PT100 interface. We have a 2-channel GPIO. Those three that we currently have in the portfolio already cover the majority of sensors and actuators that are out in the field. However, there's a couple more interfaces that we are currently working on because we have realized that there's other interface types that the clients are looking for. I mean, that's basically the rudimentary part of the data acquisition. So you attach your sensor to the Perinode, you make an adjustment in the browser to adapt the sensor, to calibrate the sensor, you set up the security, and off you go. As you already mentioned, you only have to then define which kind of MQTT broker do you want to use, and you're ready to go.
I see. So maybe to make the point clear, what's kind of your USP here, or what makes that special? So maybe we could talk about that, because a lot of customers are maybe going the typical way through the automation area, like through the SCADA system, and then get the data directly from the PLC. So what's special about the Perinet here?
Well, I think the main difference is that you don't have to touch the PLC to acquire the information that you need. And I think, well, it's a general saying, never touch a running system, right? I mean, whenever you get into things and touch them, there's a possibility that you actually create damage if you're making mistakes. Here, we basically have something that is running completely in parallel to the automation system. So call it an independent data acquisition system. That's basically the idea behind it. And you don't need to introduce it directly from the get-go. You can basically install it at any given point in time whenever you're ready to digitalize your processes.
Yeah, the fact that the Perinodes are designed for on-machine installation. So they are IP67 rated, so they're resistant, getting water splash or dust. They can be installed directly on the machine, minus 25 to 75 degrees Celsius of operation. So you don't even need to open the automation cabinet. So if you want to read the signal from an existing detector, you can just wire the Perinet to the detector. And that has tremendous savings in installation. And because they are working on single pair Ethernet with additional services provided by Perinet, you don't need to spend 1 second in configuring the network. They just connect and go.
Right. So maybe to also make sure what SPE is in this point, because maybe some people listening and say, oh, I hear this the first time. So single pair Ethernet or SPE is an Ethernet technology, right? That enables the transmission of data over just one pair of copper wires. So in the past, it was another way, I guess. And this is a development of traditional Ethernet technology, which normally would be used as at least 2 pair of wires, right?
Yeah, correct. Actually, what we are using, however, is the hybrid variant of SPE. So we have one cable with 4 wires, 2 of which are actually for the data communication. Here we use 100 megabit per second. And then we have also the power supply, which is 24 volt DC with 2 amps. So we have a total of 48 watts of system power in the segments that we are basically attaching directly to the infrastructure. So let's say it's a last meter, a last yard product, really. We don't want to replace any infrastructure items, but we basically come to acquire the data directly from the machine on the last couple of meters.
Understood. Okay. So this is the technology and the products you're using when you talk about data acquisition and standardization. What about the data processing? I guess, Jordi, you talked already about how data storage or the data processing is going. Could you explain a bit how the data processing is working then in the cloud or on-premise, wherever the data is hosted? But how does that work? Is your customer doing that? Are you doing that? How does that work?
Yeah, the typical IoT system, not the Industry 4.0 system, the typical IoT proposal is you have sensors that produce a lot of information that is sent all the way up to the cloud. And then in the cloud, you do the data processing, and then you send the information down to the user. What we're doing, we are simplifying this process. The basic signal processing is done at the Perinet level. Mm-hmm. So it's done with a device that is 3 centimeters long that can be installed directly on the machine. This is where we calculate cycle times, temperatures, etc. At the user-defined rate, the packages of processed information is sent to the MQTT broker in the Perinet edge computer. So not to the cloud, to the edge computer. And then all that stream of data is stored in a local SQL database, also at the Perinet edge computer. So basically the customers, they have the capability, the ability to control the weather. They can decide if they want clouds or no clouds in their system.
Right. So this is where the data analysis is taking place at your customer side, right? So the customer can choose whether they want to do OEE, for example, as a use case, or other use cases, it doesn't matter, in their own cloud application, or if they want to use the data on the edge and then do it directly on machine level. So they could decide how they want to do the data analysis part, right?
Correct way. What I was describing is our preferred way of doing it.
Yeah.
But because the whole system is based on standards and the Perinodes are MQTT clients, technically the Perinodes could be publishing the data to an MQTT broker that could be running in the cloud. So that is also very possible.
Yeah. I mean, it depends really on what clients prefer. We have found some clients that are very open to IoT platforms in the cloud. We have found other clients that are very skeptical when it comes to the data security of their information, and they rather host it on premise. I mean, we have seen both, and we are catering to both, as Jordi just explained.
Yeah, also when it comes to new requirements like Cyber Resilience Act and stuff like that,
Correct.
which is coming to strengthen also the digital security in the European area. So there's more and more requirements coming up. So it's good that you have that.
Yeah, actually, our products are already, like, let's say, Cyber Resilience Act ready in so far as we have certificate-based security built in. So the clients that are using our products and thereby also Zentinel products, obviously, are already ready for what's to come from the legislative perspective.
Perfect. So, by the way, if you want to learn more now about the Cyber Resilience Act, I will put in the show notes a great episode which I made talking about this topic. So I will put that in the show notes for you. Some people are listening now and say, hey, maybe I don't know, a partner or a system integrator which could help to set up also these kind of use cases. So how do you partner with other companies here? So could you explain a bit when I'm listening now and say, hey, I want to work with you guys. So how do you handle partnerships?
Well, Zentinel NDS is a company located in Barcelona, Spain, and we do have systems integrators that are working with our technology in the Spain area. So we have companies in the northwest, in the center of Spain, and we also have partners in Argentina and in Brazil. But I guess the short answer is our products are designed for ease of use. They can be used by any solution provider that understands how to connect devices to a machine. They're very simple to use from that point of view. And then from the IT point of view, we need companies that are familiar with basic technologies like SQL databases, Ethernet, TCP/IP, etc. So we're really looking forward to have more partners. What they can do is just get in contact with us, send us an email, go to our webpage, and yeah.
Perfect. So we'll put your contacts also in the show notes. So you have a look in the show notes and then you could get the contact also to Jordi or to Björn. So to follow up on these type of partnership things. I guess next year, 2025, is also Hanover Fair. I guess, Björn, you're there, right?
Yeah, we were at the Hanover Fair this year. For next year, I'm pretty convinced that we are going to be there. For the remainder of this year, we will not have our own booth anywhere. However, our products will be shown at the SPS fair in Nuremberg in November. We are also participating in the SPE forum in Munich at the end of October. So if you happen to be in Germany and you're interested in SPE as a technology, it is highly recommendable. It's a 2-day event, 1 day of workshops and 1 day of presentations. Yeah, this is where we are going to be for the remainder of the year. And then next year we'll see actually where we are going to showcase our products.
Perfect. Cool. So when you're listening to this episode before SPS, so before November 2024, take part of this on site. So I will put all the information in the show notes. And also we have a community meetup on Tuesday at 5 p.m. at OPC Foundation booth. So you're happily invited also to meet people there. So SPS will be definitely something. And then, I don't know, Jordi, Barcelona, there's also the Barcelona IoT World. Does it take place 2025 also? Or is it in the planning?
We still don't know. It just happened a few weeks ago. I think it was during May that happened. So we don't have news about the next event. But we are located here in an Industry 4.0 hub, very close to the fairgrounds in Barcelona. And together with Perinet, we organized an event coinciding with the IoT Solutions World Congress, where we have customers attending. So most likely we will do the same next year, so around the IoT solution.
Yeah, perfect. Because I was wondering if I'm attending also the Barcelona Fair next year, and we have some partners joining from Europe anyway. So it's great to strengthen the contact on site. So great. Thank you so far for this episode today. I guess I had a very good understanding how the technology is working, which kind of use cases you're addressing on a concrete example, which was like OEE, but then going into more the depth of the different technologies and the products behind that. It's great to see that you have a common like integrated solution also end-to-end for your customers together. I would like to say thank you for your time today. Thanks for all the information. And maybe we could do a follow-up episode also in a year or something to give some updates on that. But so far, thank you from my side, and thanks that you have been part of this today.
Thank you. Thanks for the opportunity.
Yeah, thanks, Madeleine, for having us. And obviously, as I mentioned, we are always working on new interface types and new interesting products. And yeah, absolutely. We will come back and present what we have to show once it's ready.
Thank you so much and have a great rest of the week. Bye-bye.